very like it. Okay, so the next question that we want to answer is, should we train an end-to-end model or should we train a modular model? Classically in robotics, people have always trained modular models. By modular models, you mean there's one module for vision, there's another module for state estimation, motion and path planning, and the last module for controllers. At Skill, we do not do this modular approach. We throw away the last 70 years of robotics literature and we train a completely end-to-end model. In our case, pixels go as input and out come motor commands. And in between, there's just one neural network. That's very critical. Our models work with pixels as input. I'm sure you are seeing a lot of fun videos on Twitter nowadays with different robots doing dancing or doing kung fu and so on. Now, these kind of tasks like dancing and kung fu, which seem very hard for humans, are actually very easy for robots. And this is called Robotics paradox. Things that seem hard are easy for robots, and things that seem easy for humans, like manipulation, is extremely hard for robots. So here is a scenario where the robot can do dancing, but when it comes to doing stairs, the robot will fall. Because in the case of stairs, you need to know exactly the stair height. You need to know how high to keep your feet and make your decision about physics. Otherwise, you will fall down. And so that is why most of these approaches do not use any vision. They are just blindly doing these actions of kung fu and so on, whatever you are seeing of military examples and so on as well. At Skill, we have built the first end-to-end visual locomotion system. This system uses the camera on the torso to do very hard tasks. So for example, it can go through these platforms one by one. You can see it will climb. This is a really hard task for a humanoid because it's making these decisions where to keep the legs so that it will not fall down. The next one is my favorite. It's a wheel platform. It can even balance on this kind of wheel platform very easily. Here, it continues to do these harder and hard tasks. We are approaching a robot to go through these debris. The idea of this end-to-end locomotion system and how effective and powerful it is. Not only it can do these kind of platforms, but it can do any stairs in the world. Again, you see a lot of these dancing robots, but you never see any robots climbing stairs. Because stairs would need the balancing and vision. And that is why none of these humanoid robots that you see out there have any of these powers. But skilled robot, the skilled brain, actually works with vision, with the camera on the torso. And it's able to do all of these tasks, especially the stairs. It's very robust. It can carry objects while going up and down the stairs. Someone can come and push it, it's still very stable. This is as I showed. Here the robot is climbing the stairs and someone is pulling from the neck. Again, very hard to balance. But now in this case, the person will get up and push the robot while it's climbing down. There is no human even who can do that. Like when you're pushing the robot, when you're getting down, you are definitely likely to fall. Then the robot can just keep climbing stairs. This is the largest stairs in the city of Pittsburgh, like the highest number of stairs. And it just keeps on going up and down the stairs for hours and hours. And it's very robust to any of all of these actions, essentially. Again, end-to-end model with vision as input. But that doesn't mean we cannot do fun. We can do parkour too. You can see these are really funny. These are much easier than climbing stairs. Again, this is Robotics paradox, obviously. You all will be super impressed by these, but these are much easier than the stairs that we were just doing.
sayang ko ngayon.
Okay, last, why are we making this only body brain? One brain that works on every body. As I was saying, robots are machines. And one thing I know about machines for sure, that machines break down. The motors will break, the limbs will break, and so on. And so if you are just using a brain that only works on one hardware, as soon as the hardware changes, you can see the robots are not able to work. Because they're only trained to walk on four legs. Now suddenly one leg is